Hello, all my science students. This is John Walker again. And in this video, we're going to talk about the interactions of matter. And this particular video could apply to almost to all my students, whether or not you're science or chemistry or physical science. So, we're going to talk about some things that go on here. So let me turn the page. This is a really good little chapter on interactions of matter. And so here's Madame Curie. Here's a picture of Madame Curie. She was back in the late 1800s, early 1900s, and she and her husband did a lot of work on using radioactivity to help people. And unfortunately, she got cancer from it. But she did win 2 Nobel Peace Prizes. Her first was in 1903, and the second one was in 1911, as you can see. And she was an incredible star in the science world. There are other people that were really incredible stars. This is Percy Julian, and he's the son of a former Alabama slave. Was one of the first African Americans to earn a PhD in chemistry. His work in discovering the chemical properties of plant steroids led to the development of medicinal steroids, which was really helpful in solving some problems. Okay, so we're going to take a look at the interactions of matter, and let's go and talk about chemical reactions. That's one of the things we've been studying, chemical reactions. Okay, so here's the vocabulary terms: chemical reactions, chemical formula, chemical equation, reactant, product, law of the conservation of mass, endothermic reaction, and exothermic reaction, law of conservation of energy. Now, if you're in my chemistry class, you need to go ahead and define those words. If you're in one of my other classes and you want to earn one of my earth science class or my physical science class, if you want to earn some extra points on this, you certainly can do so. So define those words and do some of this work as well. Okay? Here remember we just got done doing a synthesis reaction in using iron and rust and all that. So that's kind of you could take a look at that video also. Okay, what are the signs of a chemical reaction? So we're going to talk about a chemical reaction. Have you seen leaves change color in the fall or smelled sour milk? Yuck, sour milk. The changes in leaves and milk are caused by chemical reaction. A chemical reaction is the process in which atoms are rearranged to produce new substances. And we talk about reactants and products, don't we, when we do that? Okay, here's a guy going, oh man, that's yucky. Have you ever tasted bad milk? That's awful. Okay, so how are chemical reactions modeled? Okay. And you can read that. So you have a chemical equation and a chemical reaction. And I can take you back to the synthesis reaction where in this particular case, this example, we used sodium and chlorine, and we combined those two in a reaction, okay? And we made sodium chloride, or we call it table salt, okay? And that went pretty good. And then here, reactants, here the substance is carbon, which is C, and O2 is oxygen. And if we burn something, the products are carbon dioxide. Products are the substances formed in a reaction. Their chemical formulas are written to the right. Okay? Now, how do chemical equations show the law of conservation of mass? So I want you to read this, and I'll talk a little bit more about it as we go. But the law of conservation of mass simply means that mass cannot be created nor destroyed. It's got to go someplace. So we're going to learn how to balance these equations, okay? And I'll have some more of that coming up. But read this, become familiar with it, and because you're going to need it to answer some of the questions. And then you can take a look at this. Here's a pretty interesting thing where you got oxygen and hydrogen, helium, and all those coming together and creating an exothermic blast where heat is released and the rocket takes off. Okay, energy. So what happens to energy during chemical reactions? Well, energy can be absorbed and it can be released. Okay, when we burn something, energy is released, isn't it? Okay, and when we absorb it, okay, a chemical reaction that requires an input of energy is called an endothermic reaction. You got to know this. This is one of the things that you do have to know. Photosynthesis is an example of an endothermic process that absorbs light energy. Okay, photosynthesis is when, excuse me, when plants use energy from the sun to change carbon dioxide and water to oxygen and sugar. And I know you know that. Now, energy can be released as well. So energy can be absorbed and released, but it cannot be created nor destroyed, okay? A chemical reaction in which energy is released to the surroundings is called exothermic. Exothermic. And that when you burn something, that's an exothermic reaction. Exothermic reaction. Energy is always conserved. The law of conservation of energy states that energy cannot be created or destroyed. And I just talked about that. Methane, okay, CH4 burns when it reacts with oxygen, O2. This reaction produces carbon dioxide and water. That is a classic example of a combustion reaction. Okay, we'll move on to we're going to talk a little bit about the need for speed. Some things react quicker than others. Changing the reaction rate, we can make things react quicker. If we want to burn something, you know, it's obviously that's going to be quick, isn't it? But rust takes a long time, doesn't it? It's actually the same thing. It actually is kind of the combination of things coming together and you know, with the use of energy. And of course, rust takes a long time. However, when you burn something, that goes pretty quickly, doesn't it? Okay. And here's a pretty interesting article on enzymes and talking about medical conditions. So yeah, you can read that. And some visual summaries. And so you can answer these chemical reactions. And then the total amount of energy before and after a chemical reaction is, what's the answer? Okay, you should know that. You're going to have to answer it in there. And there's carbon plus O2, oxygen, equals carbon dioxide. And then here's the lesson review. Okay, it's going to have you talk, or it's going to have you answer questions on what's a reactant, what's a product. So a reactant, is it a substance that is produced by a chemical reaction, or is it a substance that participates in a chemical reaction? What do you think? Okay, it's going to ask you to describe what happens to atoms and reactants during a chemical reaction. So you're going to have to review some of the material there. You're going to have to explain, relate, compare, you know, model in this case, analyze and evaluate. Okay, you can do that though. And that is the end of that story on interactions of matter. And so you have been sent this little packet, and so fill it out, turn it in so you can get a lot of points. Now, once again, if you're not a chemistry student and you want to do this, and you can follow along and, you know, in the video and write some of the stuff down and then turn it into me and say, hey, Walker, you know, I looked at your video and I answered some of the questions that you had, and, but I'm in your physical science class, can I get extra credit? The answer is yes, you can. Okay? I like the fact that you're, you know, cross-using some of the other material in other classes. So I hope this finds you well, and talk to you soon. Bye.